the repurposing of abandoned oil and gas wells for geothermal high tunnel application. Presented by Reset and PASA Sustainable Agriculture. Reset, the Repurposing Center for Energy Transition at the Pennsylvania State University, is a new center for repurposing fossil fuel energy infrastructure for energy transition applications. The primary focus of Reset is on abandoned oil and gas wells as well as abandoned surface and subsurface mines. PASA Sustainable Agriculture is a non-profit organization dedicated to cultivating environmentally sound, economically viable, and community-focused farms and food systems. Founded in 1992, PASA offers farmer training, peer-to-peer education, applied research, and an annual conference that brings together stakeholders from across the food system. Across the United States, millions of oil and gas wells have been abandoned, often without proper sealing. These wells pose significant environmental risks, particularly methane emissions, a greenhouse gas with a global warming potential over 25 times greater than CO2. However, these same wells also represent untapped potential, deep, structurally stable conduits into the Earth's thermal reservoir. This innovative approach is a model for combining environmental remediation, food production, and community resilience through the utilization of abandoned wells for geothermal applications in high tunnel operations. Our case study focuses on the Edible Earth Farm, located in Sandy Lake, Mercer County. This site includes a vertical gas well decommissioned in 2018, extending to a depth of 1,720 meters. Subsurface temperatures at this depth reach approximately 67 degrees Celsius, making it suitable for low-grade geothermal energy extraction.
Rather than plugging and abandoning the well and leaving it inert, the well can be converted into a closed-loop geothermal system. Within a closed-loop geothermal system, a working fluid is transported through a closed piping network, mitigating any fluid losses to the formation itself. For the inlet of a closed-loop geothermal system, the water is transported between the tubing and casing, or through the annulus until it reaches the bottom. This process allows for the working fluids to interact with the rock formation and absorb the heat from the formation itself. Once the working fluid reaches the bottom of the well, it's transported to the top at the outlet through the tubing itself, where it is used then in high tunnel operations. Through some multi-physics software simulations, we're able to see the true operational capacity of the geothermal system. Flowing at an optimal flow rate of 0.1 meters per second, the geothermal well is able to produce working fluid at a temperature above 39 degrees Celsius. And at these conditions, the well is able to produce over 76 kilowatts of thermal power, conditions that are well suitable for high tunnel operations in Pennsylvania throughout the wintertime.
High tunnels, polyethylene-covered structures that passively trap solar radiation, extend growing seasons and protect crops from climatic variability. In temperate regions like Pennsylvania, however, passive heating alone is insufficient during colder months, making supplemental heating necessary. Traditionally, farms rely on propane heaters, which are costly and carbon-intensive. A geothermal solution like the one proposed at Edible Earth Farm would reduce reliance on fossil fuel heating, improve temperature consistency inside the tunnels, and significantly lower operational costs. On average, heating a high tunnel with propane costs around $6,000 annually. Geothermal retrofitting can reduce this to approximately $1,300, reflecting a nearly 80% reduction. PASA's role in this geothermal agricultural integration is multifaceted. It helps identify candidate farms for well repurposing, supports farmers through technical and financial feasibility assessments, and advocates for state and federal incentives that reduce barriers to adoption. Moreover, PASA is involved in workforce development by coordinating with regional institutions like St. Francis University, Indiana University of Pennsylvania, and the Greater Johnstown Career and Technology Center to provide specialized training in geothermal system operation and agricultural integration. At Edible Earth Farm, these collaborations help transition oil and gas workers into new roles as technicians and geothermal system managers, creating meaningful employment pathways while reinforcing the local economy. In summary, the closed-loop geothermal integration with high tunnels offers a scalable, environmentally responsible approach to agricultural heating in cold climates. It revitalizes dormant fossil fuel infrastructure, displaces emissions-heavy heating systems, and strengthens regional food security. With organizations like PASA facilitating adoption through education, policy advocacy, and technical support, Pennsylvania is well positioned to become a national leader in the convergence of renewable energy and sustainable agriculture. This initiative represents a systems-level solution rooted in science, community development, and climate action. Thanks for watching. For more information, please visit our website at reset.psu.edu and at pasafarming.org.